Hello everyone. In this video, I am going to cover meaning of cable, use of cable, assumptions made in analysis of cable, and the procedure to be followed while analyzing the cables. Flexible cables are basically used to support the loads. Best example is suspension bridges. If you have suspension bridges, the cables are tied at top point and bottom floor to support the floor. Second example is transmission lines. Secondly, we will see assumption to be made while analyzing the cables. First assumption is the cable is perfectly flexible and inextensible. Look, we are going to assume that cable is flexible. Means whenever we will apply load at one particular point, it will move in the direction of that particular load. And there will be sag at that particular point and it is not going to extend. Second example, the weight of cable is negligible and hence neglected. You have to concentrate on this point. Like beam, we are not going to consider weight of cable. So we are going to neglect weight of cable. Third one, the cable has only tensile force which is directed along the cable. In my previous video of Lamy's theorem, I have explained that whenever there is cable or string, the nature of force going to act along that segment is always tensile in nature, means it will act away from the point. Next, the length of cable is constant before and after the application of load. So the length of cable remains unchanged whenever you will apply load or before the application of load. Next, we will see procedure to be followed while analyzing the cables. For explaining this procedure, I have taken one example. Let us say the cable ACDB is supported at point A and B with the help of hinge support. And we know at hinge support there are two reactions. One is vertical and another one is horizontal. Let us say the horizontal distance between point A and C is L1, between point C and D is L2, between point D and B is L3. Let W1 is the load applied at point C, and due to this application of load, the point C has shifted vertically downward from this AB line by a distance YC. Now this YC distance is known as sag or deflection at point C. Let after the application of load W2 at point D, the point D has shifted vertically downward from this line AB by a distance YD. Here I have considered that the sag at point C is known for us and we have to determine the sag at point D, which is YD. The first step to be followed while analyzing the cable is to draw free body diagram for this given problem. So we will draw first of all free body diagram. Look, you have to draw the same sketch. Instead of showing these supports, now here we have to show reactions. Now how to show reactions? Look, we have seen the tensile force is directed along the cable. Now if you see this part AC, whatever is the tensile force developed in this part will be the same force which is going to develop here at point A. So RA is equals to tension between point A and C. So whatever is the line AC, you have to extend the same line from point A in opposite quadrant. Now look, if this force, if you observe this force has came in second quadrant, and we know in second quadrant its x component is acting always towards left side and y component is acting vertically upward. Hence AX will act on leftward side and AY will act vertically upward. Similarly, if you observe point D, point B, whatever is the force in this segment of cable DB will be the same force RB. Now while showing RB, you have to extend this line DB from point B to the opposite quadrant. Now since this line is in third quadrant, your RB will come in first quadrant. Now we know in first quadrant its x component acts horizontally rightward and y component acts vertically upward. Now after showing these forces, how to show this tensile force? Now look, from point A towards point C, you have to show arrow going away from point A. Similarly, if you consider this point C, the force should go away from the point. So this arrow is going towards this side and this arrow is going towards this side. So this is tension T1 which is acting in part AC. Similarly, tension between part CD will be T2 and tension in part DB will be, let us say, T3. Let us say above this point C there is C dash point along this line AB and point D dash above this point D. Let us say this T1 makes an angle theta 1 with respect to this horizontal line, T2 makes angle theta 2 with respect to this C point, and T3 makes an angle theta 3 with respect to this point B, okay, with respect to this horizontal axis. Now we will show the forces and we will move for ahead. Let us say sag at point C is known, YC. So first step we have shown these forces, okay. Now here W1 and W2 are active forces and T1, T2, T3, AY, AX, BY, BX, RA, RB, all these are reactive forces. So after drawing this FBD, we have shown all active and reactive forces. Now next we have to apply conditions of equilibrium. Now if you observe this force system, all forces are not meeting at one common point, they are meeting at different points. So this is example of non-concurrent force system, and we know for non-concurrent force system we have to apply three conditions of equilibrium, that is summation Fx equals to 0, summation Fy equals to 0 and summation M equals to 0. Now we will apply first equilibrium condition, that is summation Fx equals to 0. For applying this condition of equilibrium, I have to assume some sign conventions. So here I have going to consider forces going towards right side will be positive and forces going towards left side will be negative. Now if you observe this force system, there are only two horizontal forces, AX and BX. Now look, according to my sign convention, after applying the equilibrium condition for summation Fx equals to 0, my condition will become minus AX plus BX must be equals to 0. Now here I have written same, minus AX plus BX equals to 0. So we can say AX equals to BX. So this is my condition number 1. Now I will apply second equilibrium condition, summation Fy equals to 0. For this I am going to consider vertically upward forces positive and vertically downward forces negative. Now if you observe this free body diagram, vertical forces are AY, W1, W2 and BY. Now according to my sign convention, this will become plus AY minus W1 minus W2 plus BY must be equals to 0. I have written same equation over here. Now AY plus BY equals to W1 plus W2. This is my second equilibrium condition. Next, I will apply third equilibrium condition, summation M about A equals to 0. I am going to take moment of all forces about point A, and since this force system is in equilibrium, it must be equals to 0. So for this moment, I am going to consider sign convention as clockwise moment negative and anti-clockwise moment positive. You can assume other sign conventions also, doesn't matter, your answer will remain same. Now consider this free body diagram. I am going to take moment of all forces about this point A. Now since AY and AX, these both forces are passing through this point A, its moment about point A will be 0. Similarly, if you extend this line of action for BX force, it is going to pass through point A. So hence again moment of this BX point about A will be 0. Now take moment of remaining forces. Look, W1. Now this force is going to rotate in clockwise direction about point A. So for this W1, its moment will be negative according to my sign convention. So moment is product of force into distance. So moment will be minus W1 into its distance from point A is L1. So this will become minus W1 into L1. Next force is W2. Again it is going to create clockwise moment. So W2 into its distance from point A will be L1 plus L2. So it will become minus W2 into L1 plus L2. Next force is By. Now if you consider By force, it is going to rotate in anti-clockwise direction about point A. So its moment will be plus, according to my sign convention. So plus By into its distance from this point will be addition of all these three lengths. So L1 plus L2 plus L3 must be equals to 0. I have written same over here, minus W1 into L1 minus W2 into L1 plus L2 plus By into L1 plus L2 plus L3 must be equals to 0. From this equation, W1 L1 is known, W2 L1 L2 is known, L1 L2 L3 is known, unknown is only By. So from this equation you will get vertical component of reaction acting at point B, which is By. Now after getting By, use equation number 2. Here in equation number 2, now By is known, W1 and W2 are given, so unknown is Ay. So from using this equation you will get value of vertical reaction component acting at point A, which is Ay. Now after getting Ay and By, our next aim is to get horizontal component acting at point A and B, which is Ax and Bx. So for this you have to consider the part of cable, and by applying moment at that point you have to get values of Ax and Bx. Now how to consider, which part we have to consider for analyzing the values of Ax and Bx? For analyzing Ax and Bx, always you have to consider the part of cable where sag is known. Now if you observe this free body diagram, we have assumed that the sag at point C is known. So you have to consider part of cable AC. So if you consider this part cable AC, it will help us to determine value of Ax, because here value of Ay is known, the distance L1 and this distance Yc is known to take the moment. Now I have shown with the different sketch this part. Now look, this is Ay, this is Ax, this is part of cable AC. Let us say this point is C dash. We know the distance between A and C dash is L1. The distance between C dash and C is sag at point C, which is Yc. Now let us take moment about this point, C point. Why we are taking moment about C point? Because we have to determine the value of Ax. If you take moment about point A, these two components will become 0. So we will take moment about point C. Now what will happen after taking moment about point C? According to my sign convention, now look, Ax is going to rotate in anti-clockwise direction. So moment of Ax about point C will be Ax into distance between these 2 points is Yc. And if you consider this point force Ay, it is going to rotate in clockwise direction. So according to my sign convention, Ay will create negative moment about point C, and the distance between Ay and this point C is L1. Remember that whenever you are going to consider horizontal force, consider vertical distance for taking moment. Whenever there is vertical force, consider horizontal distance. So my equation will become plus Ax into Yc minus, because it is going to create clockwise movement, minus Ay into L1, which is distance AC dash, must be equals to 0. Now if you observe this equation, here Yc is known, Ay already we have calculated, the distance AC dash means L1 distance, so unknown is Ax. So from this equation you will get value of Ax. From equation 1 we know Ax must be equals to Bx, only their natures are different, magnitude is same. So by using equation 1, you will get Bx also, which is equal in magnitude as that of Ax, only its nature is opposite to Ax. Next step, we have to find support reactions. Now how to get support reaction? So you have to use this formula, Ra equals to Ax square plus Ay square. Look, this is the reaction, Ra, reaction at point A. So always reaction is calculated as x component square plus y component square and square root of it. So Ra will become Ax square plus Ay square. So from this equation you will get value of Ra. Similarly, if you consider Rb, it will become Bx square plus By square, square root of this value. So from this you will get value of Rb also. Next, we have to find maximum tension in cable. Now how to find maximum tension in cable? Here I will give you one trick. Always maximum tension acts where inclination is larger with respect to horizontal axis. Now look, always maximum tension will act near the support. Means you have to find Ra and Rb. So whichever will be the maximum reaction, so your maximum tension will act at that point, and at that point your angle of inclination with respect to horizontal will be larger one. For this, what you will do, compare the values of reactions at the support. The support at which reaction is maximum will have maximum angle of inclination with respect to horizontal. Hence, maximum tension will act in the cable segment which is nearer to the support having maximum reaction. So, Tmax equals to Rmax. Now look, if your Ra is more than Rb, so whatever is magnitude of Ra will be the same force acting in this segment AC. So Ra equals to TAC, tension in part AC, which is equals to T1. So in this case, if my Ra is greater than Rb, Tmax will be equals to TAC equals to Ra. Or if Rb is greater than Ra, in that case whatever is the value of Rb will be equals to tension in part BD, which is equals to T3 equals to Tmax. Now next part is finding sag at the other point where sag is not known for us. We have assumed that the sag at point D is unknown for us and we have to determine the part YD. Now we will draw separate free body diagram for the segment BD. We have noticed that the distance between D dash and D is YD. The distance between D dash and point B is, let us say, L3, which is given in figure. These are the two components which are known to us. Now already we have calculated these support reactions, so we know these values. We know value of L3, we know value of W2. Unknown is just YD. Now again, to determine this YD, I will take moment of all forces about point D. So if you consider this W2 force, its moment about point D will become 0. Now consider these two forces. Now this Bx force will rotate in clockwise direction about point D, and since this force is horizontal, the distance between these two forces we have to consider as vertical one. So moment of Bx will be minus Bx into YD. Okay. Next, we have to consider moment of this By force. Now it is going to rotate in anti-clockwise direction about this point D. Since force is vertical, distance we have to consider as horizontal one, which is L3. Now same I have written over here, By, which is plus in nature according to sign convention, By into BD dash, which is L3, minus, due to clockwise movement, Bx into YD. Now in this equation, we know value of By, we know BD dash, which is L3, we know value of Bx, unknown is YD. So from this equation you will get value of YD, which is sag at point D. Next part, we have to find tension in each part or each segment of cable. Suppose we have to find tension from A to C, C to D, D to B. Now already we have calculated RA reaction. So whatever is the reaction at point A will be same tension developed between cable part AC. Now look, value of RA is equal as that of tension in part AC, which is T1. So RA equals to T1. Now to get this inclination of T1 with respect to horizontal line, we know sag at this point C, which is YC. We know this distance L1. So tan theta 1 equals to YC upon L1. So theta 1 will be tan inverse of YC upon L1, which will give you inclination of theta 1 with respect to horizontal line. Now to determine theta 2 and T2, what you have to do? You have to draw this separate free body diagram for this particular portion. Now C dash, C, D dash, D. Now look, the sag at point D is YD, sag at point C is YC. To determine this theta 2, what you have to do? We have to extend this line up to this portion. Now we know this distance YD. So YD minus YC will give you the distance from this point to this point. Now how to get theta 2? We know this distance YD minus YC divided by L2 will give you theta 2. Same I have explained over here for calculating tension in part CD of cable. Look, this is C dash point, this is C point, this is D dash, this is D. Let us say after extending this C point horizontally, it cuts D dash D line at point P. Now to get this PD distance, YD minus YC, this distance is YC, will give you remaining distance PD. Now to get theta 2, look, theta 2 will be tan inverse of PD upon L2. From this you will get theta 2. After getting theta 2, we have to draw separate free body diagram for joint C. Now look, at point C there is W1 weight attached at point C. There is tension acting in this part TAC, which is equals to T1, which is equals to RA. And this is tension in part CD, which is unknown for us, and it is acting at an inclination of theta 2 with respect to horizontal line. So now in this free body diagram, we know value of W1, we know theta 1, theta 2 and TAC. Unknown is TCD. Now here, by using Lami's theorem or by resolving these two inclined forces and by applying equilibrium condition, summation Fx equals to 0 and summation Fy equals to 0, you will get values of tension CD, which is T2. Next we have to determine T3. Now by observing this figure, whatever is the magnitude of RB will be the same tensile force acting in part BD, and which is also known as T3. Now how to determine its inclination? So your theta 3 will be tan of YD upon BD dash, which is L3. So your tension in part DB will be equals to reaction at point B, and theta 3 will be tan inverse of YD upon D dash B, which is L3. Now here they will not ask you all these things to be determined in one single problem. They will ask you part of this. For example, they will ask you to determine reactions at support or sag at one particular point, or they may ask you reaction at the support and maximum tension in the cable, or they may ask you to determine tension in each part of cable. Hope you have understood this in very well manner. Thank you.